Good afternoon, everyone. Yeah, this is the revision part of periodic function, unit step function, and unit impulse function. And commonly, that is periodic function and unit step functions appears for SEE also. So try to prepare properly. That is periodic function. Periodic function. In PUC you have studied, that is goes to sin x and cos x, both are periodic functions of period, that is goes to 2 pi you have taken. So sin, this is if you have taken that is minus pi, here it is goes to plus pi or pi by 2, this is minus pi by 2, minus pi, this is goes to plus pi, and so on. So sin trigonometric function, what it is there, sin 0. So you are having that is 0. Sin of pi by 2, it means what? That is goes to theta varies or x increases from 0 to pi by 2. That is sin x is increases from 0 to 1. So it means what? That is goes to the curve goes like this type. It is up to maximum is goes to 1 is there. So now that is goes to again it is increases, it goes to that is decreases. Means what? As x increases from pi by 2 to pi, that is sin x or f of x, what it is there, it is decreases. So similarly, suppose if it is there minus pi by 2, it is in minimum value of that is goes to sin is goes to minus 1 and maximum is goes to, so plus 1, this is the curve. Periodic function is nothing but the period is goes to upper limit minus of lower limit, that is comes as 2 pi. So this will be extended from pi to that is goes to 3 pi, 3 pi to that is 5 pi, means what? The difference between these two terms, what it is there, that is called the period. And in this example you have taken that sine and cosine are periodic functions of period, that is 2 pi. And definition you have studied in PUC also, that is a function f of x, or here you have taken Laplace transformation, I will use the word is f of t, is said to be a periodic function. Periodic function. So of a period, that is, I am not taking the notation alpha, the minimum requirement what it is there, period is non-negative. It may be pi by 2, it may be pi, it may be 2 pi. If and only if this condition is satisfied, then only f of t plus of alpha, this is equal to f of t. Okay. So for example, sin t you are considered, sin of t plus of 2 pi, 360 plus theta comes in the first quadrant, again it is goes as sin t. So it means what? There is no change in, so that is the functional value when you are changing the variable plus of the period, it remains as it is. And in this example, that general function what it is there, this one. And in the Laplace transformation, one theorem what it is there, LT of periodic function. And to solve the examples, the entire Laplace transformation, this is with the proof. This is the only one theorem is there with the proof. Either the theorem comes or that is goes to based on the periodic function example comes. So that is if f of t is a, what is the statement is there, that much I am writing. If f of t is a periodic function of period alpha greater than 0, then your target is to show that Laplace transformation of f of t, this is equal to 1 divided by 1 plus of e raised to, so that is alpha s 0 to alpha. So this is e raised to kernel of the transformation into functional, what it is given to you. This is the statement. Sometimes what it is, the state and prove the periodic function theorem. Otherwise, the statement will be given to you if f of t is what it is written, the same thing, and you have to derive that is this one by using the help of the definition of Laplace transformation. Yeah, proof what it is there. So I'll write it in this format. So proof. Okay. Given that I am writing. So it is given to you, it is a periodic function of period alpha is nothing but I can write it as t plus of alpha equal to f of t. What the statement is there, I written symbolically. This is given to you. Now the second step, what it is there, that is for definition of Laplace transformation, we have, what the basic definition you have taken the Laplace transformation, the same thing you are writing here. Laplace transformation of f of t equal to, so this is 0 to infinity kernel of the transformation into the functional relation, what it is given to you. Okay, this is the general definition. What the LHS of the general definition is there, the same thing is present in the LHS of the periodic function also. Only the answer is different. Now, using the help of the period, so I am writing in this place. This is equal to, in PUC, one of the property of the definite integration, that is f of x into dx is equal to a to c plus of c to b. This is comes as f of x into dx and f of x into dx. One condition what it is there, where you are taking the break, that should be more than the lower limit, less than an upper limit. And in this example, period is known to you. How to take a break, you can see that. Starting is 0, ending with the period. Now second one is, starting with upper limit, ending with the period. What you are writing the upper limit, that should be this term minus of this term should be equal to the period only. This is goes as 2L. 2 alpha, this is 2 alpha to 3 alpha. So this process is continuously goes, I'll write it as equation number 1. Means what, using the help of the properties of the definite integration, the continuous function you are converted into discontinuous. This is e raised to minus sc into f of t dt. E raised to minus sc f of t into dt. This is also e raised to f of t into dt. There is no end, up to infinity it is goes. Now you can see that the requirement is 0 to alpha. So present is 0 to alpha. It means what? Not necessary to think it about, that is first integral. Only the second integral. Functional relation is present as it is, but the limits are changes. Requirement says that 0 to alpha, present is goes to alpha to 2 alpha. Therefore, only you are changing, that is these the integrals can be evaluated by using the help of the substitution. Yes, in the second integral of RHS of 1. Second integral is nothing but that one. So you are substituting, so put, so independent variable t equal to, other than t, any variable you take, so that is presently I am taking x. So plus of, that is goes to period, lower limit of that integral, particularly what it is, the lower limit of that integral. Substitution for except the first integral, remaining all integrals. Independent variable is equal to, any variable you can take, it is not necessary that x you have to take. What you need you can take plus of the lower limit. So that is the second integral is having alpha. Either your substitution is correct or not, you will come to know that after changing the variable. Just a moment, you see that dt equal to, that is dx. When the variable changes, the limits of integration may or may not be changes according to what you have studied. Now is there any change there or not there, you have to see that. Also, when t tending to, what is the lower limit of that particular integral is there, you say that is alpha. New variable x tends to what? When t tending to upper limit to alpha, new variable x tending to what you have to get it from this substitution. When t equal to alpha, this alpha and this alpha cancels, x is goes to 0. So that is when you substitute t equal to 2 alpha, so alpha is shifted, it comes as, that is this one. Means after the substitution, new variable limit has to be compulsorily 0 to alpha, 0 to alpha, 0 to alpha. Suppose if you are not getting this much, so your substitution is wrong, and it is not so difficult to remember the substitution. I have told it that is goes to independent variable t equal to any variable plus of lower limit of that particular integral where you want to substitute. And here clearly I have written that second integral of RHS of the first equation. So now those terms should be substituted. That is alpha to 2 alpha e raised to minus st f of t into dt. Where you want to substitute, very clearly I have considered. Now in this equation, in this integral, you have to substitute it. E raised to minus s. Wherever t is there, you have to write it as x plus of alpha. So here it is comes as, so x plus of alpha and dt is goes to dx. So when t varies from here to here, x will be varies from 0 to alpha, that much I will write. So apply the indices rule and the given data, what it is there. This is alpha as it is. E raised to minus sx into e raised to minus of s alpha. And the second one is, so given itself is goes to t plus of alpha equal to this much. It means what? The periodic function variable is not important. Either t is there, x is there, theta is there, y is there. The period remains as it is. According to the given data, I will write it f of x into dx. This part is purely constant because of you are integrating with respect to x. Other than x, any notation if you are having, that should be treated as constant because period is a constant number more than 0. S is a parameter which is treating as constant. This term I will take it outside the integral. This is e raised to, either you write it alpha s or you can write it as s alpha, and this term 0 to alpha e raised to minus sx f of x into dx, or the last step e raised to minus alpha s. This is 0 to alpha e raised to minus st f of t into dt. Means maybe you are thinking that that is goes to x directly, the why it is written as a t. So here that is we are not resubstituting, because one of the property of the definite integration which is you are studied as the first property in PUC second year, f of x into dx is equal to a to b f of t into dt. This itself is called Demi variable property. Whenever there is a change in the variable, there will not be a change in the limit. Means what? Both gives to you the same answer. Either sin x you take it, sin t you take it, cos square x you take it, cos square t you can take it, a and b what you need you can take it. That is, in both the cases you will get the same variable. That is called Demi variable. One variable can be changed to the other variable. So the same property I used and written is this term. Your intention was this integration should be transferred to, that is goes to 0 to alpha. Requirement was 0 to alpha, that much we have reached. Similarly, the second integral, third integral and so on. So at least 2 integrals you substitute and evaluate it. The rest one what it is, a dotted line, we can keep it. Also, or again you can write again, that is in the third integral, of RHS of 1. So substitute, that is put t equal to new variable plus of the lower limit of that integral, that is goes to lower limit is goes to 2 alpha. Okay. So this is dt equal to dx. Also t tending to the lower limit 2 alpha, x tending to what? T tending to an upper limit 3 alpha, x tending to what? So now when t equal to 2 alpha, you will be having x is equal to 0. When t equal to 3 alpha, x will be having only alpha. So these terms should be substituted in the third integral, that much I will write. So 2 alpha to 3 alpha e raised to minus st f of t into dt. This is comes as e raised to minus of x, and here it is comes as x plus of 2 alpha into f of x plus of 2 alpha into, that is dx. New limits of integration is 0 to alpha. Okay. Yes, apply the properties what it is given to you. This is e raised to minus of 2 times alpha s. So open the bracket, apply the indices rule which is free from x, that much I have written outside. 0 to alpha e raised to minus sx into dx. Yes. The question is, the periodic function is given, period is alpha. Sin x is a periodic function of period, that is 2 pi you are taken. Similarly, that is in general you are taken. Sine and cosine trigonometric functions are periodic functions of period 2n pi. N is a natural number. It means what? 2 pi, 4 pi, 6 pi and so on. Similarly, if any function is a periodic function of that period, it can be multiplied by any natural number. The period will not be changes, that much Basis on that one, I can write it as this is f of x, or this is e raised to minus of alpha 0 to alpha e raised to minus st f of t into dt. So now here the same property is used. So now if two are evaluated, third and next what it is, they need not to evaluate it. So just you write it as so on. Don't by heart it, that is how to derive this one. It is not so lengthy. That is one point that is goes to some properties if you are remembered. One is how to take a break. Second one is this property if you are remembered. It is not so difficult to derive this much. And commonly that is theorem comes, it comes as 6 or 7 marks. And so here I am giving the explanation, therefore it may be taking little bit more time. But in exam hall what it is there, it will take maximum of 5 minutes. Okay. And what it is you are evaluated, that is the number of integrals, you substitute it in the RHS of the first equation. Yes. That is substitute, 1 becomes, I am writing, or clearly you write it, substitute it, all these values in 1. LHS of 1 was, that is goes to Laplace transformation of f of t. RHS side what it is there. No change in the first integral, what it was there, that much keep it as it is. Second integral you are evaluated, and that was e raised to minus alpha s 0 to alpha e raised to minus st f of t into dt. The third integral, it is in front of you, e raised to minus 2 alpha s 0 to alpha e raised to minus st f of t into dt. So plus of, that is so on. Okay. Now in the entire RHS side there is a one common term is there, that is called integral. So you take an integral common, what it is there, e raised to minus st f of t into dt. Okay, what are the remaining terms are there, I'll keep it inside the bracket. Entire integral you have taken, the common term is nothing but 1. So plus of this term, e raised to alpha s, e raised to 2 alpha s. Next one will be 3, 4, 5 and so on. This is equal to 0 to alpha e raised to minus st f of t into dt. Okay. Now here that is goes to this term. I will write it as e raised to minus alpha s, which is given in the question paper. That is prove that, so Laplace transformation of f of t. So I know that that is goes to, if I written directly, so maximum students will not understand. There are two ways are there. In that is series you have taken arithmetic progression, geometric progression, that is and so on. Here the number of terms are infinite. Sum of infinite number of terms, that is goes to in this term. So here that is 1 divided by 1 minus of r, or it may be 1 divided by r minus of 1. Actually you are taken a, ar square, ar cube and so on. A is the first term and r is the common ratio. Since in this a particular example, you have taken that, that is 1 is the, this in place of a, 1 is there, therefore I have taken that 1 and adjusted a equal to 1. So this is the term. Now common ratio more than 1 or less than 1, what it is there, according to that one I have written, this is one way. Second way what it is there. So here 1 minus of x raised to minus 1, binomial expansion, raised to minus 1. This is comes as 1 plus of x square plus of x cube plus of so on to up to infinity. In place of x we are having e raised to minus alpha s. Okay, and raised to minus 1 what it is there, I have shifted to the denominator. Either you are using this one or this one to write the answer. Suppose if I have not remembered both also, once if you have taken the common, that is goes to, directly you can write the answer from the question paper, because it will be printed in the question paper. Okay. Yeah, that is, this is the only theorem in the entire Laplace transformation, that is called unit 2, with the proof is there. Suppose that is goes to SEE may be having, that is the theorem proof. So or they can give it to you examples. Okay. What are the examples? The regular class we have solved. Out of that, anyone randomly I am taking one example. Just you have to see that. If Laplace transformation, sorry, if f of t equal to, so t to a minus of t. Okay. So 0 is less than or equal to t is less than or equal to a, is less than or equal to t is less than or equal to 2a. Okay. Where it is given. If it is not given also, how to understand it is a periodic function or not. So 2a equal to, that is f of t. There are two types of examples are there. The same example, just a moment, you see that. If I'll write function is same, everything is same. Only I am changing, that is limits of integrations. This is a and I am writing as more than a. Here that is goes to everything I have written. But suppose if this example, if f of t equal to this one, find the Laplace transformation of f of t is there. Then, so that is goes to either it is a periodic function or unit step function or basic definition. It is depending on, so where that is you are taking. In this example, upper limit is finite. So either 2a is there, 2 pi is there, pi by 2 is there, that is goes to upper limit minus of lower limit. It comes as one finite number, that is called period of the given example. So it means what? This term what it is there, it is a periodic. In the periodic function, yeah, here he has given to you. It is good, no problem. If it is not given also, they will ask it to you only to find Laplace transformation of f of t. This will be the question. If it is there, easy to understand, this is a periodic function. Suppose if it is not given to you, just he has told it to evaluate it, find Laplace transformation of f of t, or show that Laplace transformation of f of t equal to some answer will be maybe given to you. So at that time, so how to judge either it is a unit step function or it is a periodic function, or all unit step function examples can be solved by using basic definition also. So what it is, the original definition is there, but don't use it that one. Only how to make the difference between the periodic function or unit step function. In the periodic function, upper limit will be a finite quantity. There will be an end. Either 2a is there, 2 pi is there, pi is there, whatever may be, it will be a finite number. But in the unit step function, there is no end. More than a, it may be 2a, 3a, 100a, 1000a. It means what? Maximum is goes to up to infinity. There is no end is there. This is called unit step function. You are solving the example, that is by using the help of the unit step function. If the periodic function is there, then you are using this theorem, what the proof you have completed. So that much is using to solve. So that is periodic function. Yeah, don't expect it how I have written the function, where the word, what it is there. This stands for f of t is a periodic function of period 2 pi. It is very clearly given. If it is not given also, you should be able to judge either it is a periodic function or not. So here that is goes to solution. This, yeah, one more time I am removing this one. Given data, I will write it as it is this term. This is given. Okay. Now, by periodic function, we have Laplace transformation of f of t. This is equal to 1 divided by e raised to minus alpha s 0 to alpha e raised to minus est f of t into dt. First step is to write what is the period. In this particular example, alpha is goes to upper limit minus of lower limit. Either one point of discontinuity is there, 2 points of discontinuity is there, are there. That is irrespective of that one. Upper limit minus of lower limit. It is comes as so 2a. Wherever alpha is there, we have to write it as 2a and evaluate it. 1 minus of, so 2as, 0 to 2a, e raised to minus st f of t into dt. Yes, here the limits of integration is 0 to 2a. Okay, but the function is discontinuous. There is a bracket a. So use the property and evaluate it. 1 minus of e raised to 2as. Here one is 0 to a, second one is a to 2a. So completed. So here e raised to minus est dt, e raised to minus est dt. Actually I have to write it f of t directly. I am substituting what it is given to you. In the range 0 to a, the functional relation is given to you f of t equal to t. And the second one is, what it is there, you can see that a to 2a, the functional relation is goes to 2a minus of t. And these integrations can be evaluated by using either integration by parts or it may be generalized rule of integration by parts. Okay. Exponential into algebraic and not used t or t square or t cube. Okay. Exponential into algebraic, that is trigonometric into algebraic. Commonly will prefer to evaluate those examples by using the help of generalized rule of integration by parts. So what is that? One by one we'll take and evaluate it. This is in the flower bracket, that is first integration I am writing, and the second flower bracket I am writing the second integral. Here exponential term, that is should be kept as it is. Yeah, 1 minute. That is u into dv, integration by parts. U into v minus of integration you are taken. In generalized rule, only the change is after the first step. This is comes u dash v1, u double dash v2 minus plus minus plus. Irrespective of sign of both the terms, the series is alternately positive and negative, and here, which is the first term is there, that should be successively differentiated, dashes notations are there, and phi should be integrated successively. Suffix notation I have written. U is nothing but exponential term. Algebraic term should be taken as, that is goes to, 8 minutes. Reverse I have told them. Algebraic term always taken as a differential part, exponential or trigonometric function should be taken as integral part. Means what? Actually I have to write t into e raised to minus at. So that is goes to 2a minus t into e raised to minus st. U is nothing but algebraic term. Whatever may be it, either 1 minus t is there, t square is there, t is there. Irrespective of the sign, try to keep it, that is in the open bracket. Now integral of the exponential term e raised to minus st divided by minus s. This is the second term. Now irrespective of sign of both the terms, our series is alternately positive and negative. Differentiated the first part, it is comes 1. Again integrated the second part. So this is minus s already there, existing. E raised to minus st, one more time integration, what happens? E raised to minus st divided by minus s, one more time comes, that much I am writing, so this term. Now next term will be, actually it is plus sign. Differentiated, that is first open bracket. Its differentiation is goes to 0. It means what? Which term you are written first, successively you have to differentiate until you will get it a constant number. Further need not to write. Don't see that what it is there, how many times you are integrated, only you have to so concentrate it on differential part. Limits of integration presently it is 0 to a. The same thing will be repeated for the second integral. This is algebraic term should be considered as differential part u, and exponential term should be considered as an integral part. Again integration of e raised to minus st. So this is minus s, minus of, this minus is irrespective of sign of both the terms. Now minus of derivative of this term, it comes as minus 1. 2a is 0, minus t is minus 1. Again integration, what it is there, e raised to minus st divided by minus s comes, so already one s is there, so that much I written that square. This is a to 2a, so completed. This is completely outside the square bracket, okay. So this is equal to 1 upon e raised to minus 2as. 1 upon, this much I have kept as it is. Substituted the upper and lower limit for each and every term. This is minus 1 by s. Only first term you concentrate it, because of integration is not difficult, but simplification little bit you have to concentrate it, because one sign changes, the entire answer changes. So minus s I have kept as it is. T into e raised to minus st is there, you have to substitute upper limit minus of lower limit. Wherever t is there, upper limit is a, e raised to minus of as. Wherever t, either s into a you write or a into s you write. Minus of the lower limit, t itself is 0. So this is 0. Okay. Now come to the second term. So minus s whole square is plus. Okay. So divided by s square. Upper limit minus of lower limit, only exponential term is there. E raised to minus as, e raised to either minus 0 or plus 0. So which one you need, you write. Second term is completed. Come to the third term. minus 1 by s as it is. So upper limit minus of lower limit. So when you will substitute upper limit, that is t equal to 2a, 2a minus of 2a is 0. So it means what, need not to substitute it here. Lower limit, what you will get, that much will substitute. So here that is t equal to a. 2a minus of a is a, and here it is e raised to minus as. So this term is completed. Now lastly, this term. Minus s whole square is plus this minus into this minus is plus 1 by s square. So upper limit, e raised to minus 2as, e raised to minus of as. The entire term is completed. Okay. Now here you can see that minus a into e raised to minus as divided by s. Here 1 by s is in this place. Minus into minus is plus. Same term is there with opposite signs. Means these two terms can be cancelled directly. Out of the two terms, that is goes to remaining two terms, what is common is there, we'll think. Here also 1 by s square, there also 1 by s square. I'll write it 1 by s square is outside. Okay. Now here, this is e raised to 0 is 1. Minus into minus is plus 1 comes. This is e raised to minus as. Now that side, e raised to minus as plus e raised to minus 2as. Only 4 terms are remaining. That is, while taking the common term, this minus sign is adjusted in between these two terms. I have written totally answer. This is 1 divided by s square, and in this term, this much according to me, detail need not to write directly, you can simplify. E raised to minus 2as, because of both are the same. Okay. And this term, so I'll write it 1 square minus of e raised to minus as whole square, because of it is exactly in the form of a square minus of b square. Okay. So that one will simplify now. Okay. This is equal to 1 divided by s square. A square minus b square is a plus b and a minus b. A plus of e raised to minus as, a minus of e raised to minus as. Okay. Now, in this place, what it is there? E raised to minus as whole square, because of a minus b whole square is a square minus 2ab plus of b square. The same 3 terms comes here, these 2 terms cancels. So 1 divided by s square, 1 minus e raised to minus as divided by 1 plus of e raised to minus as. Yeah, beginning only I was told it, sometimes they will give it to you, find the Laplace transformation, sometimes they will give it to you, prove that the Laplace transformation of this term is equal to something. Now you think it, that is presently I have written that is find, means what, somebody will think it as this is the end. Because of somebody will think that without simplification, this one also they will make it as end. Okay. But further simplification is possible. At least you have to write up to this term, minimum simplified answer. Now, so still that is goes to, suppose if the answer is given. So what the answer is given to you in this example, until you will get it, that answer you have to simplify. Okay. What the simplification is possible in this example, you can see that. 1 divided by s square. Okay. So one term you have taken. So tan hyperbolic theta equal to e raised to, that is theta, e raised to minus theta divided by e raised to theta plus e raised to minus theta. Sin hyperbolic theta upon cos hyperbolic theta. This is the way. Only one term is present in place of one more e raised to theta. You are having unity. So that much. Yeah, 2 ways I will give it to you. Suppose if you know that is goes to thoroughly, basic formula is you have to adjust it in this way. Okay. Here I will write it as e raised to as by 2. Inside is e raised to minus as divided by e raised to as by 2. 1 plus of e raised to minus as. Means what? Multiplied and divided by the same term. So both cancels, previous term remains as it is. Okay. Now this is equal to, take it inside. This is, take it inside. E raised to as divided by 2 minus of e raised to minus as by 2, because of Indices rule. Bases are same, powers must be added. Denominator is goes to e raised to as by 2 plus of e raised to minus as by 2. Okay, or so that one, this one, both are the same. Tan hyperbolic of as divided by 2. So if the answer is given for this example, the maximum simplification, so will be this one. Okay. Now you can see that up to here you have reached. So you are unable to adjust it this one. Very simple. If the answer is printed, print it. So reverse order, at least you have to remember this formula. Okay. Now you have to think it, that is goes to the comparison. Up to here you have reached. But ours is 1, here is extra. What extra is there, take common. But only what it is there, don't cancel it, these two terms. Means reverse order also in forward order also it will be matching. Okay. So try to see that is goes to whenever the answer is given to you, to prove that until you will get the answer you have to simplify. If the answer is not given, somebody will say that may be the answer, somebody will think it that is goes to this is the answer. But at least you have to write up to here. It is not necessary, not compulsory to reach up to here. But once if the answer is given, compulsory you have to reach. And most of the cases in Laplace transformation, that is goes to periodic functions, standard examples are there, answers may be given to you. Chances are more. If not given, at least what the best you can simplify, so you have to simplify it. Okay. So one. Yeah, one more, that is unit step function. Yeah, theory is already given to you, that is regular class. Okay, because second unit. Theory will remember, because in this periodic function, that is unit step function, only they will give it to you for the SEE point of view, that is example. What is the unit step function is there? Everybody you know that. Unit step function u of t minus of a, you have taken that is goes to 0 or 1, and Laplace transformation, everything you have taken. So that is goes to 0 is less than t is less than, that is goes to a t is greater than a. So inequality, equality, what it is there, that may be printed. And the Laplace transformation of unit step function also you have completed with the proof, that is goes to e raised to minus as divided by s. Okay. Now that is goes to one theorem you are completed, that is called Heaviside step function. Heaviside step function, what it is you are taken, that is only remember, because this is the theorem statement is using to solve the example, and in generally, so that is unit step function you will be having an example, that is like express, that is in terms of Heaviside step function, hence find their Laplace transformations. Therefore, I am concentrating because it is a revision is there. So just I am giving the statement, I am not taking the graph or anything. Everything is given in the regular class. So which is important for the examination point of view. So that much I am writing. Heaviside shifting theorem. Shifting theorem. Okay. So what is there, that is you can see that if Laplace transformation of f of t equal to f of s, conditional, if it is known, then only you are able to evaluate it, then Laplace transformation of f of t minus of a into u of t minus of a. So chances are there in place of this term. So Heaviside, that is called, they will write it as h of t minus of. Unit step function can be noted by u of t minus a or h of t minus of a. Okay. So which is given in the classroom, the same notation you can continue it. So I am using presently, that is u of t minus of a. Title itself it says that unit step function, therefore I am using u. So then this term is equal to e raised to minus as into, that is called f of s. Okay, or sometimes that is goes to e raised to minus as into Laplace transformation of f of t. Both are the same because of L of f of t itself is goes to f of s, and in place of f of s, some teachers may be using, some faculty members may be using f bar of s. Both are the same. Okay, so this is the theorem is there. So that is how to convert, and this much That is most important. Try to remember this theorem 1. And the second one, what it is there, the note. Yeah, question title will be there, that is expressed in terms of Heaviside step function, hence find its Laplace transformation. Okay. So what is there, you can see that. Note, compulsory you have to remember, that is these notes. If f of t is equal to, there is a one point of discontinuity. So for example, I am writing that this is f1 of t, this is f2 of t. So this term will be given 0 is less than or equal to, t is less than or equal to, and here it is goes to more than a. Okay. So only one point of discontinuity. So actually limit is goes to 0 to infinity only, more than a is nothing but it is goes to infinity only. But there is a break at one point, that is 0 to a and more than, that is at the point a is there. So then how to convert discontinuous function in terms of a continuous function? By using the help of unit step function, you have to see that. First you remember, so how to write, then how you are getting, I will explain by using the help of the unit step function. So here that is goes to, I am not using the word which is f1, f2, f3 is there, sin t is there, t square is there, t cube is there, sin t is there, 1 is there, cos t is there, or sin t, cos t, sin 3t is there. Irrespective of the notations, that is goes to, what is the first function is there, f1 of t. So plus of, every time either 1 point is there, 2 points are there, 100 points are there. So how many breaks are there irrespective of that one? So that is goes to, since it is a discontinuous function is there, we are converting in terms of a continuous function with the help of unit step function. First function as it is. So plus of second function minus of first function, that is f1 of t, into u of t minus of break point. Since it is, there is a break at only one point, so this term means what? Break is converted in terms of a continuous function. Both are equal or not, so you have to see that. Okay. Now, so when t is less than or equal to a, what is the value of unit step function? That is the basic definition of unit step function is given to you 0 or 1. So in the less than or equal to a, unit step function is goes to 0. So this is 0 into this difference is goes to, totally answer is 0. When t is less than or equal to a, always t is more than, that is 0 only. Okay. So now in this example what it is there, this is 0, balance is goes to f of t is goes to f1 of t whenever t lies between 0 and a. So same thing is present. Now other hand, when t is more than a, t is more than a, unit step function value is goes to 1. So substitute it as 1. So open the bracket, this f1 of t and this f1 of t cancels because of opposite signs. Balance is goes to f2 of t. When t is greater than a, given is f2 of t, we are also getting f2 of t. Okay. So it means what? No change. What it is given to you according to our convenience, we have written. Okay. Now similarly, this is the first note. Second note, f of t equal to, so f1 of t, f2 of t, f3 of t. f3 of t means what? A break is taken at two different points. So where it is you are taking, that is goes to a1. So a1 is less than t is less than or equal to a2 and t is greater than a2. Means what? That is goes to, there is a break at a1 and a2. So then how to convert, that is goes to continuous function f of t equal to. First you remember the major part what it is there, how to write. After writing you think it about what it is given to you, what it is you are written. Both are the same or not. First function as it is, f1 of t, plus of second minus of first function. Second minus of first. I not use any term, that is f2 is there, f of t, g of t, whatever may be it is given. Second term minus of first term into unit step function at the first point of discontinuity. Okay, used word is first point. It may be 0 to pi, pi to 2 pi more than 2 pi. Okay. So it means what? First point of discontinuity is goes to, that is pi notation. If it is there 0 to 1, 1 to 2 more than 2, first point of discontinuity is goes to unity. 1 you have to write. So plus of third term f3 of t minus of, that is f2 of t into unit step function, that is second one. That is second point of discontinuity, what it is there. Now, so what it is given to you, what you have written, both are same or not by using the help of unit step function, because of extra additional term is multiplied is unit step function. Now, suppose if it is there t is less than or equal to a1, according to the unit step function definition, a1 and here also a1, think it. Suppose if it is less than or equal to, answer is goes to 0, and according to the given data, a1 should be less than a2. That is correct. So means what? If it is there, this is 0, substitute. Since a2 is also more than a1 is nothing but this is also goes to 0, this is also goes to 0, balance is f1 of t. Less than a1, it goes to what it is there. 0 is there. So this term 0. When it is less than a1, it has to be less than a2 also, because of a2 is more than a1. This is 0, this is 0, balance is goes to f1 of t. Now other hand, the middle one. So what is there? More than a1 and less than or equal to a2. More than a1, answer is 1. But less than or equal to a2, answer is 0. Less than or equal comes 0. More than comes 1. So it means what? This is comes 1. This is comes as 0 for the middle one. So 0 means what? Leave it. When it is 1, f1 of t cancels, balance is goes to f2 of t. And the last one, when t is greater than a2, is nothing but t has to be more than a1 also. So therefore, in both of the cases, 1 comes, 1 and 1 here. f1 of t cancels, f2 of t cancels, balance is goes to f3 of t. It is correct? Yeah. This is the way, that is question title, what it is there. Express the following function in terms of Heaviside step function, hence find its Laplace transformation. Means any example if it is given to you. Okay. So first step is to express this type, then the second one what it is there to find out the Laplace transformation. Yeah, for that, okay, one important thing that is goes to, yeah, I am using one method, the other faculty member may be using the different method, but the end will be the same. So in this place you see that, yeah, we have, I am writing, that is already Heaviside step I am writing, that is you are taken u of, sorry, f of t minus of a into u of t minus of a. Okay. What is the answer is there? It is known to you. E raised to minus as into f of t. F of t. This is, there it was written f of s or Laplace transformation of f of t. Now, this is theoretically, compulsory theoretically, this is the function, this is the unit step function. But the practically what will be there? So, most important is this one. Try to remember, if it is f of t into u of t minus of a, unit step is multiplied only f of t sin t into u of t minus pi, that is t square into u of t minus of 2. So means